Hey guys, so I just messed up my last video, so sorry, there's some stuff already written down. But section 8.2 is about trigonometric ratios. So a trigonometric ratio is a ratio of two sides of a right triangle. All right, and there are three trig functions that we're going to talk about. There's six in total, but we're only going to talk about the first three for now. So a sine ratio. So the sine of an angle is the ratio of the length of the leg opposite, to the angle to the length of the hypotenuse. So let's look at an example here. So the sine of A, I want the length of the leg that's opposite, so A, over the length of the hypotenuse, which is C. All right, for angle B, I want the side that's opposite, so side B, over the hypotenuse, which is C. Okay. Then we have our cosine ratio. So the cosine of an angle is the ratio of the length of the leg adjacent. Hopefully you remember what the word adjacent means. So adjacent to the angle to the length of the hypotenuse. Remember, a ratio is a fraction, right? That's what we did for sine. We're going to do the same with cosine. So for cosine of A, we want the leg that's adjacent. Well, adjacent means next to. So here's angle A. The leg that's next to it would be side B over the hypotenuse. And then for angle B, I want the leg that's adjacent to it. That would be A over C. I know it's a little weird at first. Just bear with me, okay? We're going to talk a lot about it. Sorry. The tangent ratio. So the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So for example, the tangent of angle A would be A over B, and the tangent of angle B would be B over A. Again, we're going to talk about it, so I'm not going to waste your time talking about it here. So before we even talk more about trig ratios, we're going to talk about why we need them, okay? So we've learned how to find missing parts of a right triangle, right? So we've done Pythagorean theorem. So we know that c squared is equal to a squared plus b squared. We use Pythagorean theorem if we know two sides of a right triangle and we're looking for the third. Okay, that's the only time we can use Pythagorean theorem. If I only know one side, I can't use Pythagorean theorem. If I know something about angles, I can't use Pythagorean theorem. I only use that when I know two sides of the right triangle and I'm looking for the third. All right, so in this case, we'd have x squared equals 8 squared plus 6 squared, because we know x is our c value. And we would get x squared equals 100, so x equals 10. That you should be pros at by now, right? Option 2. Well, let's look at option 2. We've got a 45, 45, 90 triangle. All right, well, with a 45, 45, 90, we know we're in the ratio of 1, 1, root 2. So across from our 45s, we're going to put 1s. And across from the 90, we'll put a root 2. So we can only use these ratios, though, if we have a 45, 45, 90, right? If we have another triangle, these ratios don't work. They only work for 45, 45, 90s. So in this case, we'd end up getting y equals 9 and x equals 9 root 2. I want you guys to go through and see if you agree with me there, okay? But I'm not going to spend some time doing that because we should already be pros at it. Option 3 then is for a 30, 60, 90 triangle. So 30, 60, 90, they're in the ratio of 1, root 3, and 2. But again, that only works for 30, 60, 90 triangles, right? So if I'm looking for sides of a 30, 60, 90, I use those ratios. So across from the 30 is my 1. That means this must be a 60-degree angle, by the way. So that's my root 3, and then this is my 2. So I end up getting that y is equal to 9 and x is equal to 9 root 3. Again, you can go through the work of solving those, but those should be the answers that you get. Okay, but the first one, we had two sides of a right triangle. We didn't know anything about the angles. Second option, we knew it was a 45, 45, 90, so we got to use our ratio there. Third one, we know it's a 30, 60, 90, so we use those ratios. But what happens when we have a triangle like this? It's a right triangle, so that's good. I know one side, and I know that that angle is 35 degrees. So we can't use Pythagorean theorem because we only know one side. We can't use Pythagorean theorem if we don't know two of the sides, because otherwise we're going to have two variables, right? We can't use 45, 45, 90 or 30, 60, 90 because the angle that we were given is 35 degrees. The given angle is 35 degrees, not 45 or 30 or 60. It's 35, so we can't use it. That's where trigonometry comes in, all right? That's where we're going to use these trig ratios. So let's talk a little bit real quick about those trig ratios again. So the first one that we talked about was sine. Okay, so the sine of an angle. Well, let's first talk really quick about the abbreviation for it. Okay, so sine we actually abbreviate as SIN. Not too much of an abbreviation, but still sine. And then we have to put an angle inside of it. So it could be like sine of angle A, it could be sine of X, it could be whatever variable we want to put in there. A lot of times we use this symbol right here actually. Okay, this symbol right here is called a theta. All right, it's a Greek letter. Whoops, let me move that over so you can see. Theta. It's a Greek letter, all right, and a lot of times that's what we use when we talk about trigonometry, all right? Instead of using x, theta is kind of our go-to for angles. So, for example, I can write sine, and then theta is just a circle with a line through it in the middle, like that. Okay, so sine of theta. Well, we said in our notes before that the sine of theta is equal to the opposite side over the hypotenuse. Okay, so this is opposite over hypotenuse. Then the cosine function, cosine, so we abbreviate that as COS, so cosine. And again, I'm going to put my theta. So the cosine of theta is equal to the adjacent side over the hypotenuse. Right? These are the notes that we took on that first page. I'm just now putting it into stuff that's a little bit easier to understand. So the ratio for cosine is adjacent to hypotenuse, so adjacent over hypotenuse. And then our tangent function, we abbreviate that as TAN. So the tangent of theta, well, that's the ratio of the opposite to the adjacent. So opposite over adjacent. All right, so OPP stands for opposite, HYP stands for hypotenuse, ADJ is adjacent. I think you guys can get that. So there's our sine function, there's our cosine function, and here's our tangent function. So those are going to be super important, okay? Now remembering that can get a little kind of crazy, right? That's a lot to remember. So we have this little trick for us, okay? And actually, if you look at the next page, it's on there. So look at the top of the next page, and it's got so, ka, toa. All right, that's a way to help us remember which ratios, or which sides the ratios use, okay? So, S-O-H, well, if we look, we said that sine is equal to opposite over hypotenuse. So that's the first part of our memory trick, all right? So sine is opposite over hypotenuse. All right, then the next part is ka, C-A-H. Cosine is equal to the adjacent side over the hypotenuse. And the last one is toa, tangent. All right, tangent is equal to opposite side over the adjacent side. So this right here, this SOHCAHTOA, you're going to hear me say it a lot for the rest of the chapter. It's pretty much going to be our go-to. All right, SOHCAHTOA is going to help us out so much. But you have to know how to spell it, okay? SOHCAHTOA. All right, so let's take a look at how we actually do some stuff with this, okay? So the sine of angle A. All right, well, sine, according to my memory trick up here, sine is my opposite side over my hypotenuse. So before I even start doing any of these, I identify where angle A is. So there's my angle A. The side across from it is my opposite. So there's my 5. That's my opposite side. Then adjacent, well, that means that it's the leg that's next to my angle. So that's this side right here. That's my adjacent side. And the hypotenuse, that's always easy to identify. Right? The hypotenuse is across from our right angle. Now I just use SOHCAHTOA. So the sine of A, well, that's equal to the opposite over the hypotenuse. So the opposite is 5. The hypotenuse is 13. So I'm actually going to write really quick. Opposite over hypotenuse, just since we're doing this the first time. But opposite is 5. Hypotenuse is 13. That's it. If we could simplify it, we would, but there's nothing to simplify, so that's it. Okay. Cosine then. Cosine is, according to this up here, adjacent over hypotenuse. So I want the adjacent side over the hypotenuse. And if I look at my triangle, I labeled the adjacent side as 12. So it's 12 over 13. And then tangent is equal to opposite over adjacent, which means I want the opposite, so 5 over the adjacent, which is 12. So opposite over adjacent, that means we're going to do 5 over 12. And that's all we have to do with something like that. Okay, if I'm simply just asking you to write the trig ratios, that's all you have to do. Just tell me which one's the opposite, hypotenuse, and adjacent, and then put them in the correct order. Okay, so let's take a look at number 2 then. So sine of z. All right, well, z is right here. So before I do anything, I want to figure out where's my opposite, where's my hypotenuse, where's my adjacent. So if it helps, start with the hypotenuse. Here's my right angle, go across from it. That's my hypotenuse. All right, and then here's my angle z. Well, the side across from that, if it helps, draw yourself an arrow going across. That's your opposite side. And then the leftover side, that's your adjacent. All right, and then we're going to use SOHCAHTOA. So the sine, let's look over here real quick. Sine we know is opposite over hypotenuse. So looking here, opposite is 21, hypotenuse is 35. So 21 over 35. And then this one we can actually simplify. So I want you to simplify it, okay? If you're ever not sure, just plug it in your calculator. It'll simplify it for you. But both of those are divisible by 7, so we get 3 over 5. Okay. Cosine is next. So the cosine of z, I want the adjacent over the hypotenuse. That's the ka part of my SOHCAHTOA. So adjacent is 28 over the hypotenuse, which is 35. So 28 over 35. And again, that can simplify down, so that simplifies down to 4 over 5. And then tangent, that's my opposite over adjacent. So my opposite is 21 over my adjacent, which is 28. So the opposite over the adjacent, and I can simplify that down. That becomes 3 over 4. All right, once you label your 3 sides, you just use SOHCAHTOA and write the ratios. Okay, we're going to do the next 2 actually together in class. Okay. Then we've got up here, we kind of already talked about this, right? SOHCAHTOA. I promise you writing this down each time you do these problems is going to help you. Okay, so SOHCAHTOA is going to be our lifesaver. So in order to solve problems using trig ratios, we have to be able to pick the correct ratio. So for these problems, that's all we're going to do is pick the right ratio. All right, so what we're going to do is we're going to figure out where's our angle. All right, So in number 5, I was given this angle of 53 degrees. That's the angle I was given, right? Well, all right, here's my right angle. So across from that, I've got my hypotenuse. And I know that the side across from my given angle, that's my opposite. And then the leftover side, that's my adjacent. So if I were to try and figure out which trig function I would use here, I have to look at what I'm given and what I'm solving for. So in this case, I'm solving for the hypotenuse, and I'm given the adjacent. So I need to figure out which trig function uses adjacent and hypotenuse. So if we look at SOHCAHTOA, I'm looking for an A and a H. The only one that actually does that is cosine. So for this particular problem, I would be using the cosine function. And that's all we're doing for these first ones, is just figuring out which function would we use. We'll figure out how to actually solve them and set them up later. Okay? So we're going to do the same thing for number 6. Here's my angle. The side across is my opposite. Across from my right angle is my hypotenuse. And then that third side, that's the leg that's next to my angle, that's my adjacent. All right, so I have my opposite side, and I'm looking for the adjacent. So which trig function uses adjacent and opposite? So I need an A and an O. All right, well, the only one that's got A and O is T. Well, T stands for my tangent function. So in order to solve number 6, I would need to use my tangent function. Okay? Moving right along. Number 7 here. Here's my angle of 58 degrees. Across from that is my opposite side. Across from my right angle is my hypotenuse. And the leftover side there is adjacent. By the way, I'm labeling all 3 sides. You don't have to. If you can look at it and tell me which 2 you're using, that's awesome. If you can't, though, I think this is the best way to get started with it. All right, especially since this is something so new to all of you, I suggest doing it for now. Maybe as we move on, you might be able to stop, okay? But in this case, we are looking for the hypotenuse, and we have the opposite. So we're looking for a trig function that uses H and O, so I don't want to have to keep scrolling back up and down. So I'm actually going to write SOHCAHTOA right here. SOHCAHTOA. Alright, so I want to know which one uses opposite and hypotenuse. That's the first one here, so S, so that's my sine function. Alright, and the last one, here's my angle. Across from it is my opposite. Across from my right angle is my hypotenuse. And my leftover side is the adjacent. So I am looking for the adjacent. I am given the hypotenuse. So which trig function uses adjacent and hypotenuse? We're looking for an A and an H. So which trig function is that? That has to be cosine. All right, so SOHCAHTOA is going to be huge. It's going to be the biggest lifesaver for us in this chapter. We are going to finish up the rest of the problems from in here together in class. So 3, 4, and then 9 through 12. We're going to do those kind of as a warm-up tomorrow in class. All right, I will see you guys later. Bye.